Welcome back. Here's a number of stuff to go through. We might have one or two more videos, so let's see where we get to. So again, how do earthquakes impact society? Here's just a quick view, I'll explain some of these, of the deadliest earthquakes in human history. You can see a lot of them happening around the, eastern edge of Asia, closest to convergent boundary, that Pacific Ocean. A number in through the Middle East, also a boundary. You can see the Arabian Plate and the Eurasian Plate. There's a boundary right there. A number of earthquakes there, as well as you have one over here, Haiti. More on Haiti in a moment. So, of those, here they are. The number one most deadliest earthquake, it happened over 500 or almost 500 years ago. So probably no surprise there. Buildings probably not meant to withstand an earthquake of a magnitude 8, obviously, over almost 500 years ago. So 830,000 people died. That's a lot. That occurred over a 520-mile area. A lot of that due to people living in cave dwellings, cave settlements in China at the time, and just loose rock caused those caves to collapse, killing a lot of people. But right there, number two, in Haiti in 2010, 316,000 people died. So it doesn't have to be just in the ancient past. It can be recent. All right. And we just had another earthquake in Haiti this year when this video was made in 2021. Again, more on that in a second. But you look at some other ones, including not only the quaking themselves, but some of those secondary hazards, fire in the aftermath combined with strong winds, probably burning a lot of dwellings. Again, this was in 525, so we had a lot of wood dwellings. In China, hit an area that had infrastructure built without seismic consideration. So, buildings and houses not built to withstand earthquakes. Again, recently in 2004, 227,000 plus people died as a result of earthquakes, but also tsunamis as well, so inducing that secondary hazard. Look at this one. Buried by landslides, 1920, to add to it, causing many deaths due to the cold. You lose your property, you lose your house, you got nowhere to go. So the cold being a secondary hazard as well, or just weather in general. 1923, again, large fires broke out, combined with a large tornado. What kind of Sharknado event was just happening there? You got an earthquake, you got a fire, you got a tornado. It wasn't going well in Tokyo, Japan in 1923. But in any case, this is just a list of the top 10 most deadliest earthquakes in recorded history. Which brings us to what just occurred, at least when this video was made a couple weeks back, in Haiti, August 14th. Haiti lies right on or near the transform boundary between the North American plate and the Caribbean plate. The earthquake occurred as a result of kind of a complex strike-slip fault, transform boundaries that shear stress side by side, creating those strike-slip faults. It was a magnitude 7.2, so it wasn't a big, giant earthquake, but big enough. The Mercalli intensity value at a 9 rated it a violent earthquake. So, big earthquake. But it was rather near the surface. So the focus where the earthquake occurred was only about 6.2 miles deep. As of August 22nd, so a week after the earthquake occurred, over 2,000 people were confirmed killed, over 12,000 injured. The reason for the deaths, even the thousands, is getting pretty high because you were looking at over 136,000 buildings were damaged or destroyed. Poorer area. Infrastructure is not what it should be. Codes as far as how things are built aren't put in place in some areas because it's just poor areas, poor cities, poor nations. It happens, unfortunately. The predominant buildings in the area were just mud wall and adobe block construction. They just crumble. Some secondary effects from the quake, landslides, liquefaction, also what helped to increase the damage there. And at least so far in the year 2021, it's the deadliest natural disaster. Remember the difference between a hazard and a disaster. To become a disaster, 10 or more people killed, 100 or more people affected, certain amount of economic damage, certain amount of relief asked for internationally, which all of that occurred. So as of right now, when this video was made, it's the deadliest natural disaster of 2021. So here is Haiti. It sits on the island of Hispaniola. It shares the island with the Dominican Republic. So the earthquake actually occurred over in this area here, sitting right along this fault. And you can see here's the North American plate, here's the Caribbean plate. You have this side-by-side transform boundary, creating these strike-slip faults. So the earthquake occurred right along this fault zone. So as far as deadliest, that's that. But as far as the costliest, let's take a look. Now, a lot of these are going to be more recent. Reason being, things are more expensive. Buildings that collapse, roadways that collapse, in modern times cost money. So there's going to be a lot more economic damage associated with more recent earthquakes. And then going back to that 2011 earthquake in Japan. Magnitude 9.1, so one of the 5 that's only been 9 or above. $360 billion worth of damage, almost 16,000 deaths associated with that. All right. But if you look, Japan, China, right near the Pacific Plate and its boundaries. Turkey, Italy, near boundaries between the Eurasian Plate and some of the other plates. Chile, down in South America. New Zealand, all of these are just really near plate boundaries. And even in the U.S., a couple to crack the top 15, the 1994 Northridge earthquake in California, only a 6.7. I say only, it's still big, but $49 billion damage, only 57 deaths. And then the 1989 Loma Prieta earthquake, more on that in lab, $10 billion in damage, 63 deaths. As far as, that's the world. And as far as the U.S. is concerned, again, the Northridge and Loma Prieta. And then as you start to kind of go down the list, it really drops off. Some things that stick out, for instance, the 2001 Nisqually earthquake in Washington State, 6.8, $2 billion, only 1 death, and that was from a heart attack. I say only 1, because 1 is a small number, but it is what it is. But it was not because from the quake itself, because they had a heart attack, because they were scared. So I guess that's kind of a secondary hazard, your own body, I guess. Another thing that kind of sticks out here is the 1906 Great San Francisco earthquake. Estimate 7.9. It wasn't a lot of, that was over 100 years ago, so we don't have exact measurements. 524 million in damage, but 3,000 people died. A lot of that due to secondary hazard of fire that ripped through California. And you can see some of the rest. But in the U.S., quite clearly, you can see the most costliest state to live in via, for earthquakes, California. Washington's in there, Alaska's in there, but California by far gets the biggest, causing the most economic damage here in the U.S. Now, with all the bad, sometimes comes good. Are there any benefits of earthquakes? Have you ever pondered such a notion? Think about it. Let's talk about it. So, geologic faults produced by earthquakes, that breakage and movement, and I talked about this a little bit in a previous video, but they can strongly influence the flow of underground water, oil, natural gas, so it can be useful in mining for these sorts of things, or utilizing some things. Faulting can also be responsible for another aspect of mining, that of economically valuable minerals. We talked about that when we talked about footwalls and hanging walls. And with that crack, mineral-rich water can be deposited in there. That minerals could end up being deposited themselves, creating these veins of economically valuable minerals to be mined out. So, they go to influence creating oil and natural gas reservoirs, mining out materials. Heck, they can form scenic landforms over time. Gorgeous place. Some areas around the world, owe their beauty due to the movement of plates and what they cause and or create. Plus, earthquakes themselves can be beneficial. Again, when you're building up that stress in the plates, if you have frequent smaller earthquakes, it can help to relieve that stress without it just kind of getting out of hand. I think we talked about, the bending of plates. So if we had smaller earthquakes, releasing that energy would prevent the big buildup of energy. So earthquakes themselves can be beneficial for earthquakes. Do we cause earthquakes? Do humans cause earthquakes? I think I mentioned at least one aspect in how we do that. Ponder that, shall you? I've never said that before in my life. I don't know why I just did. But anyway, do humans cause earthquakes? You betcha. You bet your bippy they do. So the actions of people have caused earthquakes in 3 ways. Loading the Earth's crust above a fault. So if there's a faulted area where the Earth is broken and we know there's movement, if you apply a bunch of weight on top of that, it could cause it to move further. So building of dams and reservoirs with large bodies of water built up behind the dam, water weighs a lot. Dams weigh a lot. Oftentimes, and I'll show you an image of this, dams are built on or near faults because of geologically how things have formed. So you load up the ground above it, well, that could shake some things below. Fracking, so hydraulic fracturing, injecting that liquid waste from this fracturing process into the ground, in essence, lubricating the faults, giving those faults, lack of a better term, again, lubrication to move and create an earthquake. And then, of course, underground nuclear explosions. I don't really think we do that anymore. There are some countries around the world that still do nuclear testing. We don't as the United States. At least that's what they tell us. No, but we don't anymore. It is illegal in the U.S. to do that, but that can very much cause things to move around, shake, activate faults. So, dams, often built above faults. There's some sort of breakage, some breakage and movement creating a fault. Looks like the hanging wall went up. Looks like a reverse fault. If there's some stream activity there, it can weather and erode, break down that material, creating a natural ledge, which would be a great place to dam up. Water behind, use the dam for a number of different purposes, but you're still building it on top of that fault. That could add pressure, add weight to it, cause it to move again. And then if that happens underneath the dam breaks, water floods down the area that it's located in. Bad news all over the place. A number of these types of reservoir-triggered earthquakes have occurred. These are just a list of a few of them back in the 60s and the 70s, and the type and the magnitude, I should say, of the earthquakes that they cause. So they can have a big impact. Hydraulic fracturing, drilling for natural gas, and we'll talk more about fossil fuels and mining thereof much later in the semester. But drilling down to access the natural gases below the ground, what they're doing is pumping under pressure hydraulic fluid. Under high pressure, if they pump it down under the ground to crack the ground itself, for the ground to release the natural gas. They suck out the natural gas. They suck out that hydraulic fracturing fluid. They save the natural gas as a fossil fuel to burn, but then they take the waste fluid, the hydraulic fluid, pump it back underground into waste reservoirs, again, thus lubricating any ancient fault that may be there, but also possibly creating new faults to begin with as you're exploding or cracking the rock underground. More on fracking when we talk about mining of fossil fuels later in the semester. But in any case, you mess around with stuff underground, things might shake and move. All right? Here are some fun songs to watch. These maybe not so much required, but they can be helpful in remembering some of this stuff. Some of these songs are kind of cheesy, I get it. But if it helps you remember the material a little bit, why not? Check them out. All right, so that brings us to the end. We did it, hooray! So what are some of the big or main ideas as it pertains to earthquakes? So some stuff to focus on as far as what may be assessed. Some of the basics behind earthquakes, how they occur, where they occur, including some information maybe in Arizona where they might occur on that seismic belt. Types of faults, normal, reverse, strike, slip, how you can identify each of those. How we measure and locate earthquakes, Richter magnitude scale, modified Mercalli intensity scale, and all those impacts on society, both good and bad, right? Bad, deaths and cost. Good, benefits. That's all I got. Before I do, let me give you one last part of the super secret code. It is the number 7. You got me? The number 7. One more time. Number 7. That's it. We'll stop there. I'll see you next time for Unit 4. Bye-bye.